Right, I'm looking at these two angles right here. These first two angles, this is number 35 from section 2.7. And this angle are two angles I'm dealing with. I'm also dealing with this one, but these are the two that jumped out first because I recognize them as corresponding angles, right? They're in the same side of this transversal. One's inside, one is outside. They correspond to where they're at in their placement amongst this grouping of four. So these are corresponding angles. And corresponding angles, if the lines are parallel, which they are, if the lines are parallel, corresponding angles will be congruent. So that means that the 3x minus the 15 is going to be equal to the 105. They're congruent, which means they have equal angle measurements. All right, so now I'm going to go ahead and solve this equation. I'm going to add 15 to both sides. So that makes 120. So 3x equals 120, divide by 3, x equals 40. So there's my x, okay? I have a couple options for finding the y. Let's see here. One option could be, well, let's see here. Hang on one second. Let me think here. One option could be, well, these two angles here are a linear pair. That'd be one option. I could also say, well, let's see here. If this is 105, and this is the route I'm going to take, if this is 105, this side over here would have to be 75 degrees because these are a linear pair, right? And these are corresponding angles, which means this would equal the 75. So I could say, all right, so y plus 25 equals this 75. That's the route I'm going to take. There's more than one way to do that problem, but that's the route I'm going to take because it's, in my mind, probably the most direct way to do it. And plus it gives me a nice easy equation to solve. So I'm going to subtract 25 from both sides. And so 75 minus 25 is 50, so y equals 50. And there we have problem number 35.